to follow me. So the first one we looked at was frequency trees, and this frequency tree example we looked at a moment ago. We had 40 people going into appointment. 23 of them were morning, so the remaining were 17. So these two arms represent how these 40 people were divided into these two different types. And then these 23 gets divided further another time by some are on time and some are late. And 21 of those 23 were on time, so the remaining 2 were late. Same here. 12 of this 17 were on time and the remaining 5 were late. So that's frequency trees. That's basically how frequency trees work. Probability trees work in a very similar way. And in fact, they can be converted from one to the other. If that many people were late or that many people took evening or morning appointments, we could also turn that into a probability. So we could say, and that's what probability trees do. They start off with probabilities. So, for example, if I did an investigation where I flipped a coin up, 1,000 times, I could start off with 1,000 here, and then say 500 of them were tails and 5 of them were heads. But rather than do them in terms of how many times I did the experiment, I'm going to talk about the probability at the start. So we say that there is a probability of half being tails and half being heads. And then if I did it again, the second flip would be half tails again and half heads again. So these are the different possibilities. The outcome could be 2 tails, which means it would be tails, then tails. The other outcome could be tails, heads, tails, and then heads. And the third would be heads and tails. So now we'd go into heads, and then the second one would be tails, or heads, heads. The big thing that you do need to understand about probability trees is this multiplication symbol, why it's used. If we're trying to work out what's the probability of 2 things happening, like a head or a tails and then a tails, we would multiply the probabilities. Okay. So what's the probability of? I'll use a text tool here. What's the probability of it being tails and heads? Again, it's going to be 0.5. Whoops. 0.5 times 0.5. It's the same probability, of course, because what's the probability of being a tails? 0.5. What's the probability of it being a head? 0.5. So again, it's going to be 0.25. Now, all these are going to be the same number, in fact, because they're all 0.5 times 0.5. So this is what I call the and the or rule. So if it's the probability of this happening, one thing happening and another thing, then we use the multiplication symbol. We multiply something. So if there's one thing happening and another thing happening, for example, what's the chance of me? What I can't think of a good example now. Like if I roll some dice, what's the chance of me rolling a 6 and then rolling a 6 again, or rolling a 6 and then a 5? It's going to be 1 in 6 multiplied by 1 in 6. So the and we use multiplication. Now we do have an or as well. In other words, I could say, what's the probability of me getting a tails or a heads and a heads? Well, it's going to be what you do then is you add. So if we're doing or, we use add. So what's the probability of it being? So I'll write it down below here. What's the probability of getting tails, or let's just underline or and bold it. Tails or heads. Well, it's going to be equal to the probability of each one added together. 0.25 plus 0.25. 0.5. So that's the rule. Let's try to understand how this answer in a different way. Let's just change the color of that so it stands out a bit better. So this we can ask the question, what's the probability of it being any one of these? Well, these are the only things. These are the only probability things that could actually happen. So the probability of it being this, or this, or this, or this must be 1. In other words, it must be certain. If I flip a coin twice, I'm either going to get tails, 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 heads, heads, tails, or tails, tails. Whereas the probability of me getting any one of these is 1. And that would mean what's the probability of me getting this, or this, or this, or this? And I would go 0.25 plus 0.25 plus 0.25 plus 0.25. And surprise, surprise, they all add up to 1. Okay? So on probability trees, this outcome probability, these must always add up to 1. This one here doesn't add up to 1. If you have a look, it adds up to 2. But however, if we assume that a tail has been flipped the first time, what's the probability of it getting a tails or a head? Well, it's going to be 1. So these two are going to be 1, and these two are going to be 1. But the outcome, they all come from the original one, and they all add up to 1. That last bit, I don't think I explained that well, but do you feel like it sort of makes sense? Sort of. Yeah. Okay, so obviously, I'll save this video now and I'll put it in your whiteboard, and you can watch this anytime. And it's bound to be a little bit confusing at the start, so we'll have a little bit of a practice. Okay, so I'll stop there.